In order to balance a chemical equation, you have to know that you can never ever change the chemical formula, which contains the subscripts. Never change subscripts when balancing. The only thing you can manipulate and change are the coefficients, the large number in front of the substance. What you need to know about coefficients is that you can distribute them. Let's say you have 5 waters. There is no subscript after the oxygen, the O. You assume that to be 1. So you distribute 5 times 1, and that's 5 oxygens, and 5 times 2, and that's 10 hydrogens. Therefore, that's what I mean by distribution or distributing. Okay, so that's what you can do with a coefficient. However, you can never ever actually change the subscripts. You can only multiply by coefficients. Okay, so let's get started. We start off with aluminum plus nitrogen yields aluminum nitride. We look on the right side, we see 1 aluminum, 1 nitrogen. We look on the left side, we see 1 aluminum, 2 nitrogens. How do we make this balance? Well, we know we can't change the little 2 there, the subscript, but we do need 2 nitrogens. So we would put 2 in front of the aluminum nitride, just like this, 2. But when we do that, we now have 2 aluminums. So then we will put a 2 in front of the aluminum on the left side. And then we check 2 aluminums, 2 nitrogens on the left side. And then we check the right side, 2 aluminums, 2 nitrogens on the right side. Therefore, we are balanced. Next question. Let's balance this chemical equation. Potassium iodide plus chlorine yields potassium chloride plus iodine. What we're going to do here is look and notice that we have diatomic molecules. We have chlorine, there's 2 of those over here, and we have iodine, 2 of those over there. Our goal is to balance, so we need to make sure we have the same number of chlorines on both sides. Well, if we look at KCl, we notice there's only 1 chlorine there. Remember, assumption, imaginary 1 is right there. So we will multiply by a coefficient of 2 because we cannot change subscripts, but we can manipulate by adding coefficients. So we now have 2 chlorines and 2 potassiums. We go to the other side and say, okay, well, if we have 2 chlorines and 2 potassiums, then we need to have 2 potassiums on the other side also. So now we'll have 2 potassiums, 2 chlorines, 2 iodines, which also happens to match the 2 iodines on the right. Check, check, check. We are balanced. Let's go to the next one. Let's say we have barium peroxide. We want to break that down to barium oxide plus oxygen. So we take the barium oxide, since we know we already have 2 atoms there, and we look on the right side, we see we have 2 atoms over here of oxygen and 1 over here, including the barium oxide. That makes 3 oxygens altogether on the right and 2 on the left. Not balanced. What do we need to do? What we could do, if we put a 2 in front of the barium oxide, then we'll have a total of 4 oxygens. 2 times 1 is 2, plus the other 2 is 4. If we do that, we then need to go to the left side and make 4 oxygens also. Put a 2 here, that'll give us 4 oxygens. But when we do that, we're simultaneously giving us 2 bariums. Therefore, we just happen to balance the whole thing, because now we have 2 bariums, 4 oxygens on the left, and then we have 2 bariums, 4 oxygens on the right. Voila! There we go. Ladies and gentlemen, we are balanced.